Good evening, students. How are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. Students, very common question to all of you. Am I audible? Is everything all fine regarding the audio and the video? Can I have your response? So, all my dear students, today we are going to discuss about the various important properties and important applications of continuous time Fourier transform. Those who are online, they can show their presence by taking parts in the comments. Students, you are all welcome here. First of all, I request all of you to hit the like button, and if you have not done so, please click the like button. And students, one more request, share the link in all your contacts so that maximum number of students will get the advantage of such type of sessions. Applications of continuous time Fourier transform. This is our today's agenda. This is the brief introduction about me. Students, I have been teaching in this domain for many years, and my subjects of interest are engineering math, signals and system, and analog circuits. Students, you are all aware that GATE AIMER'S series is already on. It started from 14th of November, and this particular session is the part of this GATE AIMER'S series only. Your favorite Ravindra Dubey sir, an alumni of IIT Kharagpur, is going to take a session on 6th of December. Yes, tomorrow 8 p.m. on our app, BYJU'S Exam Prep app. So this session will be relevant for GATE 2024 aspirants. Who are aspiring for GATE 2024, you should not miss out this. For joining this session, you need to first download our app. GATE and ECE test series. Students, the link of this test series is given in the description box. Don't forget to open that link and explore it. On your screen, you can see the various features of this test series. So, all set? Yes, students, can I have your response? Response is needed from every one of you. Students, all set for the first question? Yes. So, what is that question? An input signal x of t e raised to minus 2t u of t is applied to an ideal low pass filter with frequency response h of omega is 1 or cutoff frequency omega c and 0 otherwise. We have to find this cutoff frequency omega c such that the energy in the output is half to that of the input energy. It's a very nice question. Students, this is our signal x of t e raised to minus 2t u of t. We can calculate its Fourier transform. What is the Fourier transform of e raised to minus 80 u of t? Students, can I have your response? If you have not subscribed this channel, I request all of you to subscribe this channel so that you can comment. So all my dear students, Fourier transform of e raised to minus 2t u of t, it is 1 upon 2 plus j omega, and we will denote this by x of omega. Yes. Now students, I am interested in the energy of this signal x of t. We can calculate energy of this x of t either by using the time domain signal or by using its spectrum. So energy of e raised to minus 80 u of t is 1 upon twice a. 1 upon twice a, where a is this coefficient of t. So 1 upon 2 times 2. So 1 by 4 joules will be the energy of this signal x of t. Now student, what happens? This signal x of t is further passed through a low pass filter whose response is being given here. I'll rewrite this response. H of omega is given as 1 when mod of omega is less than omega c, and it will be 0 when mod of omega is exceeding omega c. Omega c is the cutoff frequency. So students, concentrate here. This is the low pass filter. X of t is the input. Corresponding output is y of t. Students, can I have your response? Are you all following? What is y of t? बोलो बच्चा. Y of t क्या होगा? Y of t will be input signal convolved with the impulse response of this filter. Now, when we take the Fourier transform, is y of omega. X of t's Fourier transform will be x of omega. X of t's Fourier transform will be h of omega. Yes, I can see some response. X of omega. What is this x of omega? See here. This is x of omega. 1 upon 2 plus j omega. Multiplied by h of omega. Now students, very simple, that h of omega is available from minus omega c to plus omega c. So this output y of omega will also be available in that interval only. And otherwise, that is outside this will be 0. Comfortable everyone? Students, once you respond, it will be an energy source for me. Y of omega. Y of omega is this one. Now we are interested in the frequency, yes, the energy contained in this y of omega. Energy will be 1 by 2 pi. Which theorem it is? Parseval's theorem. Integration from minus infinity to plus infinity. X of omega modulus square d omega. Very good. So students, देखो बच्चों, this x of omega, it should not be x of omega. Since you are calculating the energy for y of omega, this should be y of omega. This y of omega magnitude will be 1 upon under root 2 square plus omega square. On squaring this, good evening, TRB Poly ECE 2022. What's your name, beta? क्या नाम है आपका? You are from which place? Can I have response from every one of you? Can I request all of you to hit the like button? Stay tuned for the next 45 minutes to get the best of the concepts. Y of omega. So this will be from minus omega c to plus omega c. Now this is y of omega. What will be its magnitude? Its magnitude will be 1 upon under root 2 square plus omega square. Very good. Sharp. On squaring it, you will get, welcome Minu, 1 upon 2 square plus omega square and then d omega. Students, a simple integration formula. 1 upon 2 pi. Integration of 1 upon 2 square plus omega square. It is 1 by a tan inverse omega by 2. 1 by 2 tan inverse omega by 2. And limits are from minus omega c to plus omega c. And hello. So, bacha, it is 1 by 4 pi. What is the upper limit? Upper limit is omega c. So you need to replace this omega by omega c. Tan inverse omega c upon 2. Lower limits minus. What is lower limit? Minus omega c. So this minus will come up front and minus will become plus. So this will become 2 tan inverse omega c by 2. So energy in the output signal EY, it will be 1 by 2 pi tan inverse omega c by 2 joules. So students, we have obtained energy in the output signal. We have already obtained the energy in the input signal. Energy in the input signal is 1 by 4. Now what they have given, क्या दिया है उन्होंने, see here, we have to find omega c, find omega c, we have to find omega c, that is the cutoff frequency of this low pass filter, such that energy in the output half to that of the input. Output energy half to that of the input. This is the equation we have to follow. Output energy is half that of the input. Output energy is half to that of the input. Output energy is half to that of the input. Yes, sir. So, EY will be equal to 1 by 2. And what is this EX? This EX is 1 upon 2 pi tan inverse omega c by 2. EY and EX we supposed to substitute here. Just a moment. Anji. What is this EY? 1 by 2 pi tan inverse omega c by 2. Pure mathematical question. 1 by 2 pi tan inverse omega c by 2. And on the right hand side we are having 1 by 4, which is energy in the signal x of t, and then further multiplied by 1 by 2. Correct? So students, tan inverse omega c by 2, this will be 2 pi upon 8, that will be pi by 4. So omega c by 2 will be, Anji, tan inverse will be brought to the right hand side. So tan pi by 4, और tan pi by 4 कितना होता है? Tan pi by 4 is 1. So cutoff frequency for the low pass filter will be 2 radians per second. This is the final answer. So this question is being asked in various exams, GATE, ECE, semester exams, many exams, many times, and this variety is frequent. So you just go through it. If you have any issues, any doubt related with this, then just raise it in the comment box. If everything is all fine, then just post me a proper comment. Yes. Students, all fine? Can I have your response? Next. See this question. Students, this question seems to be a mathematical integration question, but we can solve this question using the Parseval's energy theorem. See here. If you are having a signal e raised to minus t of t, then its Fourier transform will be 1 upon 2 plus j omega. Correct? Very good. If you divide this theorem, which particular signal I should start with? E raised to minus 2t by 2 plus j omega. Is 2a upon a square plus omega square. Start with that. Better I should start with this one. Both sided exponential. Tent signal. Tent signal. You know tent signal? No, sir. This is the tent signal. e raised to minus a. In place of a, I am having 2. E raised to minus 2 mod of t. So 10th signal will look like this. Students who are trying to comment but not able to comment, for them I want to give a message that you need to subscribe this channel and wait for some time, and then you will be able to comment in this comment box. Okay, so this is exponential decrease, this is exponential rise, correct? So all my dear students, if it is e raised to minus a mod of t, then its Fourier transform is 2a upon a square plus omega square. This is the formula. If you put a equal to 2 and e raised to minus 2 mod of t, then its Fourier transform will be 4 upon 2 square, यानी कि 4. 2 square means 4. 4 plus omega square. Correct? Yes, sir. So this is my signal x of t, and the corresponding Fourier transform is x of omega. Great. Now, students, we have a theorem called as Parseval's energy theorem. Before applying that theorem, if you calculate the energy, in this exponential signal, you will find that the answer is 1 upon A, that is 1 by 2 joules. So 1 by 2 is the energy in this signal. Okay, the same energy should be obtained if you calculate the energy in frequency domain. So students, what we will do by Parseval's theorem, energy in this signal x of t is 1 by 2 pi minus infinity to infinity x of omega modulus square d omega. Great. So बच्चा लोग 1 by 2 pi हाँ जी minus infinity to infinity x of omega, this is x of omega, its modulus square will be 4 square will be 16 and 4 plus omega square whole square. And this energy, superb Surajit Rabidas, and this energy is 1 by 2. Great. So this pi is brought to the other side, divide by 2. Okay. So minus infinity to infinity, 2 gets cancelled, 8 here, 2 here. So minus infinity to infinity, 8 upon omega square plus 4 whole square. The beautiful answer will be pi by 4. The answer for this integration, not pi by 4, pi by 2 होगा ना भाई. Got it? So we have solved this question using what? We have solved this question using Parseval's theorem, not by the conventional integration techniques. Next, keep on hitting the like button. Don't forget to hit the like button. Varun bhai, welcome to the session. Ram Ram. See this. For the signal g of t, a upon a square plus t square. Determine the essential bandwidth. B of g of t such that the energy contained in the spectral components of g of t of frequencies below b 99% of the signal energy of g of t. Very nice question. Here. Here. If you have e raised to minus a mod of t, then its Fourier transform will be 2a upon a square plus square. By duality property, you know duality property? See here, this is our x of t, and the corresponding, should not write in this, should write this way, x of t, and this is corresponding Fourier transform. This will be called as x of omega. Keep on hitting the like button. Students, don't forget to hit the like button. Subscribe our channel. By duality property, what is this property? See here, all my dear students, please concentrate here and keep on responding. See, in this x of omega, if this omega is replaced by t, then you will get capital X of t. So you can also calculate now the Fourier transform of capital X of t. So Fourier transform of this capital X of t will be 2 pi. In this small x of t, t should be replaced by minus omega. So what is capital X of t? In this capital X of omega, in this x of omega, replace omega by t, 2a upon a square plus t square. So its Fourier transform will be 2 pi small x of minus omega. This is small x of t. In this t, t is replaced by minus omega. And students, 2a upon a square plus t square. Fourier transform. Take the screenshot. Take the screenshot, everyone. 2 pi. Hello. 2 pi e to the power minus a. Mod of minus omega and mod of omega, one and the same thing. So all my dear students, we have obtained the Fourier transform of this signal g of t. This signal is g of t. We obtained the Fourier transform of this signal g of t, and this is nothing but g of omega. Now all of you must take the screenshot. Students, I have got this one. Now we have got the time domain signal g of t. We have also got the frequency spectrum g of omega. Now we will be calculating the energy of g of t. So students, by considering these signals, this signals g of t energy, if you calculate, what you will get, the total energy. Low, we will be calculating this total energy. Very good, Surjit, very good, shabash. What they mentioned, that we need to consider only that spectrum such that the energy contained in the spectral components of g of t below b the 99% of the total energy. Okay, now I will be coming back on your screen. Yes sir, see here. This is omega, this is your g of omega. This g of omega is a tenth signal, so 2 pi e raised to minus a mod of omega. Got it? So students, understood? Yes sir, we got it. The total energy in this spectrum is E, and they are saying that there is a band of frequency from minus B to plus B. If this band of frequencies covers 99% of the total energy, the total energy in this spectrum energy of G of t. Let us assume that it is E. Total energy is E, and they are saying that in the band of frequencies from minus B to plus B, the energy is 99% of this total energy E. So what is this bandwidth? Is this frequency B? That given question. Okay. So बच्चा लोग writing here E1 energy in bandwidth. Okay. What is this E1? E1 is here. E1 is 99% of the signal's energy. Okay. So 99% means 0.99 times of E. Understood everyone? I respond करेंगे. So energy in the band of frequencies E1 is, since we are using frequency spectrum, so it is 1 by 2 pi band of frequency minus B to plus B, and here I will be writing G of omega modulus square. And 0.99 means 99%. 1 by 2 pi minus infinity to infinity G of omega modulus square du. Now students, I need your attention here. This E is representing the total energy content in this spectrum. Okay. So in order to calculate the total energy content, you need to integrate from minus infinity to plus infinity. And in order, if you multiply this by 0.99, you will be getting E1. So E1 is 99% of the total energy. So E1 is the energy contained in the band from minus B to plus B. Understood everyone? While calculating this, we will be cancelling out many parameters on both sides. Okay. Students, both these integrations are integrating this E1 function. So what we can do, we can just multiply by 2 both sides and make this range of integration half. This will be from 0 to infinity. Okay. Now putting the value of G of omega whole square. So 2 pi whole square, that is 4 pi square, will be there on both sides, cancelled out. Then e to the power minus a mod of omega d omega. The moment you need to square it, right? Square करना है भाई. And this mod of omega on the positive side will be positive. Similarly, e to the power minus 2a omega d omega. Comfortable everyone? Sir, where are those coefficients? 2 pi square and 2 pi square present on both sides, they cancelled. Multiplied by 2, this also multiplied by 2. Now what happened? Cancel कर दीजिए, शहीद कर दीजिए. Okay. Now 0 to b, integrating this one, e raised to minus 2a omega. E raised to minus 2a omega का integration. Students, on minus 2a, what are the limits? 0 to b equal to 0.99. हाँ जी. Again, e raised to minus 2a omega upon minus 2a. Limits are from 0 to infinity. Very good. You can cancel these constant terms on both sides, correct? Okay, sir. Now, e to the power minus 2a capital B, lower limits minus e raised to 0 is 1, 0.99, and e raised to minus infinity will be 0, lower limits minus e raised to 0 will be 1. This is minus 0.9 plus 1, 0.0. So students, if I take log on both sides, then on left hand side I am getting minus 2a. 2 a. Can I expect the answer from your side? This is B minus log 0.01 upon twice A. Can you please calculate this? This is the answer. B is frequency, so radians per second will be the unit. Come on, fast, respond कीजिए. Next, see this question. Now this question is based on the concept of distortionless transmission. Consider a transmission system h of omega with magnitude and phase response as shown in the figure. When input signal x of t equal to 2 cos 10 pi t plus sin 26 pi t is given to the system, the output will do that. To hide myself first. See the screen, entire question should be visible to you. Now see here, our x of t is 2 cos 10 pi t plus 26 sin 26 pi t. Now students, our input signal is containing two frequencies. Omega 1 10 pi radian per second, omega 2 pi radian per second. What else we can do? Please concentrate that this is the amplitude response. On this amplitude response, I am going to mark 10 pi and 26 pi. 10 pi will be somewhere here and 26 pi will be somewhere here. For 10 pi frequency, the system is offering a gain of 2, and for 26 pi frequency, system is offering a gain of 1. So for omega 1, gain factor is 2, and for omega 2, gain factor is 1. Comfortable with this? Again, 10 pi. 10 pi somewhere here, 26 pi somewhere here. For 10 pi and 26 pi, for both of these frequencies, the phase response is offering the same characteristic. So we need to find out the expression for this one. Okay, so theta omega, it is a line passing through origin, so its slope will be minus times omega, correct? Yes, slope will be negative. So yes, y2 minus y1, y coordinate is pi by 2, here y coordinate is 0, upon difference of x coordinates minus 30 pi minus 0, that is minus 30, yes 30 pi you should write, minus sign is already considered, so minus 1 by 60, that is minus omega by 60. So omega is minus omega by 60. So for 10 pi, what is theta? When you put omega 1 equal to 10 pi, what is theta 1? Tell me. So it will be minus 1 by 6, minus pi by 6. And when omega 2 is 26 pi, theta 2, 26 pi upon 26 pi upon 60 minus 13 pi by 30, correct? So just tell me what are these values? Theta 1 minus pi by 6 minus 13 pi by 30. Okay. So student, I have got x of t. After getting x of t, I will be finding out y of t. So in this x of t, gain will be multiplied. K1 will be multiplied. K1 is 2. 2 multiplied by 2. That will be 4 cos 10 pi t. What is theta 1? It is minus pi by 6. Then K2 multiplied with this second term. So 1 into sine 26 pi t minus 13 pi by 30. This should be the required output. 4 cos 10 pi t by 6 and sine 26 pi t minus 13 pi by 30. Check which answer is correct. Option C is the correct answer. Next. See this question. The system under consideration is an RC low pass filter with R equal to 1 kilo ohms and C equal to RC low pass filter. So students, this is our, what we will do, consider the Laplace transform. Laplace transform of R will be R, Laplace of C will be 1 by C, x y of S, and this one will be x of S. So y of S will be Anji. Y of S will be total supply, that is x of S, into same impedance 1 upon SC on total resistance R plus 1 upon SC. So y of S upon x of S. This will be h of S. 1 upon SC on SRC plus 1 upon SC gets cancelled. Students, I'm just replacing this S by j omega. I will get frequency response 1 upon 1 plus j omega RC. Very good. This is our frequency response. In this frequency response, what we are expecting? We are expecting that h of f denotes the frequency response of RC low pass filter. H of f denotes the frequency response of RC low pass filter. Okay, F1 be the highest frequency component such that Okay, F1 with the highest frequency component means F1 is the cutoff frequency, right? Okay, so its magnitude should be 1, correct? Okay, sir. Still one data is missing here. I'll just copy. Should be. It should be less than equal to 0.95. Then only we can proceed. Okay, sir. So students, in this I am putting this cutoff frequency F1. So H of F will be 1 upon 1 plus J 2 pi f RC. Okay. So H of F1 will be 1 upon F1 RC. We want its magnitude. So where is that denominator? Denominator is 1 because H of F, ideally it is 1. Got it? Now what we can do now? Squaring both sides. Brought it to the left hand side. Students, what I am saying that if you put R and C values here, R is 1 kilo ohm and C is 1 microfarad, and solve this, you will find that the threshold value for F1 is greater than equal to F1 will be 53.3, near about 50.3 hertz. You need to perform the calculation. R is 1 kilo ohm and C is 1 microfarad. That you can do. So the possible answer is 52.2. Okay. Yes, sir. See this. This question is based on the Nyquist rate. So x1t sine 200 pi t upon pi t. So students, this is the signal. For this particular signal, this one is our f is 100 hertz. F is 100 hertz. Now, this is the only frequency component contained in this. Okay, sir. Now, F max. This is the F max. Nyquist rate is 2 times F max. Nyquist rate is 2 times F max. So this will be 200 hertz. Nyquist, once the Nyquist rate is obtained, its reciprocal will be simple Nyquist interval. X2p, same term is multiplied. Okay, it means x1t multiplied with x1t, correct? So when, okay, what is this? Is this frequency component of x1? Sir, it was 100 hertz. So f max will be f max. If two terms are multiplied together, f max will be 2 times f1. So Nyquist rate will be 2 times f max. So 400 hertz should be the Nyquist rate. Then we have series x3, 5 cos 1000 pi t plus 4000 pi t. Student, if you divide this by 2 pi, you will get one frequency component, that is 500 hertz. And if you divide this by 2 pi, you will get another frequency component, that is 2000 hertz. So when two components are multiplied together, f max will be addition of these two. 2000 plus 500 will be 500 hertz. So Nyquist rate of this third question will be double to this, that is 5000 hertz. Yani ki, okay, whenever a signal is convolved, the Nyquist rate will be the minimum of the two individual frequencies. Upon e raised to minus 60 u of t and sin 80 upon pi t. So students, for this e raised to minus 60 u of t, you transform 1 upon a plus j omega, correct? Okay, sir. So its maximum frequency f1 will be infinity, correct? Arey bhai, this is spectrum is looking like this, so maximum frequency will be infinite. For sin 80 u of t, sin 80 upon pi of t, Fourier transform is rect omega by twice a. So maximum frequency will be minus a2 plus a, that is a only. A. So students, f max, this is in hertz, hertz में f max will be minimum of infinity comma a by 2 pi. Answer will be a by 2 pi hertz. So Nyquist rate will be double to this. So 2 into a by 2 pi will be simply a by pi. Got it? And see this last one, sync 100t and 3 sync square 60t. Now see, this is sine 100 pi t, 100 pi t, 3 sync. Sync can be converted to sine theta upon theta. So sine 60 pi t 160 pi t whole square. Correct? So students, what is F1 here? F1 is 50 hertz. What is F2? F2 is 60 pi divided by 2 will be 30 into 260 hertz. So F max will be maximum of these two. So Nyquist rate will be double to this. 120 hertz. So students, that's all from my side in this session. Thanks a lot for being with me, and hoping that in the next class you will be more responsive. Thanks a lot. Jai Hind.